Welcome to today's Explainer. We're diving into the absolute core technology behind scaling large enterprises, cloud platforms, Kubernetes clusters, and even those cutting-edge AI data centers. I'm talking about the golden image. If you've ever wondered how tech giants go from managing 10 servers to thousands without breaking a single sweat, well, you're in exactly the right place. We are going to unpack exactly how that standardization works. To really wrap our heads around why this is such a game changer, imagine a world without it. Think about the old school way of doing things. Let's say your company suddenly needs to spin up 500 Linux servers. If an engineer sits down and manually installs the OS, sets up SSH, and configures all the tools by hand, you're looking at about an hour per server. That is a grueling 500 hours of pure, tedious engineering time. And honestly, the worst part? Every single one of those machines will inevitably have some tiny, hidden configuration difference. It's just a massive, completely avoidable pain point. Now, contrast that manual nightmare with the reality of using a golden image. When you build the image perfectly just once and then clone your virtual machines from it, deploying a new, fully configured server takes just 3 to 5 minutes. That's it, 3 to 5 minutes for a perfectly standardized, enterprise-ready node. That right there is the true superpower of standardization, and it's exactly what we're going to master today. So here's our roadmap. First, core principles. Second, the 6 layers. Third, fatal mistakes. Fourth, automated builds. And fifth, scaling to Kubernetes and AI. Let's jump in. Section 1, core principles. A lot of folks tend to think making a golden image is just installing Linux, downloading a few tools, and hitting the snapshot button. But no, a true golden image is way more rigorous than that. It is a strictly validated, enterprise-grade Linux-based template. It's pre-configured with your exact security baselines, your essential monitoring and logging agents, and your compliance rules, all baked in before it is ever packaged up. This image acts as your ultimate source of truth, ready to be deployed instantly as a VMware template, an AWS AMI, or whatever format your environment demands. A truly rock-solid golden image is built on 5 absolute laws. First up, consistency. Every single host must run the exact same software versions, right down to the specific Linux kernel and bash release. No exceptions. Second is security. We're talking pre-hardened SSH, lockdown firewalls, and strict CIS benchmark compliance right out of the gate. Third, automation. You simply can't rely on manual tweaking. The image has to be built for tools like Ansible or Terraform. Fourth, maintainability, which means absolute strict version control. And finally, extensibility. Your image needs to be flexible enough to adapt, whether it's running on-prem VMs, in the cloud, or powering AI clusters. Let's talk about maintainability for a second. We have all been guilty of chaotic file naming. Final.image, final v3, please work, final.image. But in an enterprise environment, that is a total disaster waiting to happen. Best practice demands strict programmatic versioning like Golden Image v1.0. You absolutely always need to know exactly which version is actively running in production. Section 2, the 6 layers of design. Think of building this image like building a highly secure house. Layer 1 is your OS base, and the secret here is a minimal install. No graphical interfaces, no browsers. This massively shrinks your attack surface. Layer 2 brings in your essential system packages, the actual tools engineers need like Vim, Perl, wget, tcpdump, and Git. Layer 3 handles time services. Keeping all your system clocks perfectly synced with Cronity or NTP is absolutely crucial for debugging. Layer 4 is all about logging, baking in agents like FluentBit. Layer 5 handles monitoring, for example, setting up Node Exporter on TCP port 9100 to scrape your metrics. And finally, Layer 6 tops it all off with your security agents, making sure heavyweight threat protection like CrowdStrike or Defender is active from second 0. Section 3, fatal mistakes to avoid. Okay, we are entering the danger zone. There are certain things you should absolutely never, ever bake into your template. First up, SSH host keys. If you leave these in, all your cloned machines will share the exact same cryptographic key. That's a catastrophic security vulnerability. Second, machine IDs. Duplicating those completely breaks how systems identify themselves on the network. Third, old DHCP leases will cause wild network collisions the moment your clones boot. Fourth, historical log files just bloat your image for no reason. And finally, it should go without saying, but never bake in hard-coded user passwords like admin/admin. Just don't do it. So what's the actual fix here? Well, before you capture that final image, You have got to wipe the machine ID. You do this by running the truncate command. This basically guarantees that when a freshly cloned machine boots up, it generates a brand new unique identifier. And as for those user passwords, you should let initialization tools like Cloud Init or Ansible dynamically inject fresh credentials the very first time the system boots. Section 4. Automated builds. Listen, modern enterprises are not doing any of this by hand anymore. They rely on a strict, codified pipeline. Step 1, install the OS. Step 2, apply all the latest patch updates. Step 3, run those heavy security hardening scripts. Step 4, install all the monitoring agents and run compliance checks. And Step 5, capture and export the final image. Running this exact sequence as code guarantees absolute, unbreakable consistency every single time. In the real world, the industry-standard tool driving this whole pipeline is HashiCorp Packer. It automatically powers through those 5 steps we just talked about. Usually, Packer is paired up with Ansible, so Packer provisions a temporary VM, and then Ansible swoops in to configure everything, turning all your settings into pure code. Once it's done, Packer automatically exports the final result to AWS, Azure, VMware, or wherever you need it. It's essentially the holy grail of infrastructure as code. Section 5, Scaling to Kubernetes and AI. When you're dealing with really advanced environments, the rules bend just a bit. If you're building an image for Kubernetes nodes, you'll definitely want to pre-install heavy components like Containerd and Kubelet. But here is a massive warning. Do not pre-join the cluster during the build, and absolutely do not leave any old certificates lying around in the Kubernetes directory. If you do, your nodes will have an identity crisis and your cluster will fail. On the flip side, if you're building for an AI data center with massive GPU clusters, you definitely want to pre-package the NVIDIA drivers and CUDA toolkits. Baking those massive files in ahead of time shaves off crucial minutes, letting your AI nodes boot up and start processing almost instantly. I want to leave you with this really powerful mantra. The goal of a golden image isn't to make Linux boot, but to make every Linux look exactly the same. When your infrastructure explodes from 10 servers to 1,000, you quickly realize you aren't managing operating systems anymore, you are managing standardization. The golden image is the absolute bedrock of all automated operations. So, I have to ask, if your company's infrastructure had to double in size tomorrow, would your foundation actually hold up, or would it crumble under the sheer weight of manual configuration? Thanks so much for joining me on this explainer, and I hope you're ready to crush your next massive deployment.